A lot of people are familiar with MRIs. They hear about people going to the hospital and getting an MRI. MRI stands for magnetic resonance imaging. And this gets used for imaging injuries to the knee or to the rotator cuff or concussions, these types of things. It's actually become so commonplace. ESPN SportsCenter talks about MRI Mondays, where they recap all the injuries from the weekend's games. But the same technology that's used in magnetic resonance imaging in the hospital is also used by scientists in the laboratory to image small molecules. As scientists, we call it nuclear magnetic resonance spectroscopy, or NMR spectroscopy for short. NMR spectroscopy works because each atom in the molecule acts like a tiny bar magnet. The nucleus of each atom spins and gives off a magnetic field. Here at Northwest Missouri State University, we have a state-of-the-art Bruker 300 megahertz ultra-shield NMR spectrometer. At the heart of this instrument is a superconducting magnet. The superconducting magnet is cooled to cryogenic temperatures using liquid helium, which is just 4 degrees above absolute zero. And the liquid helium is in turn cooled with liquid nitrogen, which is over 200 degrees below the freezing point of water. So when the sample is placed inside the instrument, each atom in the molecule, which is acting as a magnet, gives off a radio signal. Just like your car's radio can tune in your favorite radio station, the instrument can detect the radio frequencies that are given off by these atoms in the molecule. The radio waves that the nucleus in each atom gives off is unique, and these radio waves can be detected by the instrument. The instrument will take these radio waves from the receiver. It'll do some mathematical calculations to transform the radio waves into a spectrum. And by using this spectrum that we get from the instrument, we can see the way the atoms in the molecules interact with each other. A molecular scientist can monitor a reaction as two molecules come together to combine and make a new product. Protein scientists can watch as proteins fold and twist and give us insights into how those proteins behave in the cell. Here at Northwest Missouri State University, our students use the nuclear magnetic resonance spectrometer in a variety of courses. They would use it in organic chemistry, inorganic chemistry synthesis laboratory. They'd use it in special investigations in chemistry and undergraduate research projects that we have the students work on. So NMR spectroscopy continues to be a very powerful technique in the laboratory, just like MRIs are powerful for doctors in the hospital.